Already looked at how to solve equations with variables in the radical. Let's now talk about what happens when one of our solutions doesn't work, or maybe when we have no solution at all. Sometimes when we solve an equation, particularly equations with radicals, we get answers that don't work, and we call these extraneous solutions, from the word extra there. Extraneous solutions are solutions to an equation found by solving which don't make the equation true, and here's an example. Let's start with our original equation, x is equal to 3. Now if we square both sides, we get x squared is equal to 9. And our apparent solutions are both 3 and negative 3. So we take the square root of both sides, square root, and we get that x is equal to 3 because 3 squared is 9, but also negative 3 squared is 9. So both of those are our solutions. However, 3 is equal to 3, but negative 3 is not equal to 3. So this x is equal to negative 3, that is not a solution. So we'll call that an extraneous solution. And the only way to tell most of the time whether we have an extraneous solution is by checking our answer. So we always want to check by substituting that original answer into the original equation. So we would substitute both 3 and negative 3 into our equation. Let's look at a couple of examples. We have our first example. N is equal to the square root of n plus 12. So let's go ahead and solve that using skills we already have that we've used. The first thing we want to do is get rid of our radical, and we can do that by squaring both sides. So we'll square n, gives us n squared, and we square this side to get n plus 12. And this vaguely resembles a quadratic. So let's go ahead and get all of our terms on one side and 0 on the outside. So we'll take both of these, we'll subtract n and subtract 12 from both sides. That's going to give us n squared minus n minus 12 is equal to 0 because these cancel out. Now we have a standard quadratic problem. And we'll go ahead and break that down into two factors. We know that we've got an n here on both of them, and since this is negative, one is going to have to be positive, one is going to have to be negative. If this is a negative 1n, we need two factors of 12 that could give us 1 when added or subtracted. So in this case, we know 4 and 3, when you subtract them, you get 1. So we'll take the largest one, which is 4, and we'll put it on the negative sign because this end result needs to be negative. It needs to be negative there. And this one will be positive. So if we were to quickly check it, we get n squared outside, negative 4n, inside, plus 3n. That gives me my negative 1n, and then negative 12. So we have our two results. And let's go ahead and solve that out. We know that n plus 3 then is equal to 0, right? And we know that n minus 4 is equal to 0. N then is going to be equal to negative 3, and n is going to be equal to positive 4. So we have two solutions, but will they both work? Well, let's plug them in and see. All right, so we'll know that negative 3 should be equal to the square root negative 3 plus 12. And we know that 4 should be equal to the square root of 4 plus 12. And let's work that out. Negative 3 plus 12 is the square root of 9. And is negative 3 equal to the square root of 9? No, it isn't. That solution is extraneous. It won't work. So let's try this one. 4 plus 12 is 16. So we have the square root of 16 equal to 4. Is that true? Well, the square root of 16 is 4. And this is equal to 4. So yes, in fact, this one does work. This is an extraneous solution. So you always have to check. You always have to check your answer. I know nobody likes to check their answer because it's additional work, but in these kind of problems, you have to check it. Otherwise, you may get it wrong because you chose an extraneous solution. So let's go ahead and do one more as a quick example, just to kind of let you practice as we go along. We have the square root of y plus 6, and we want to get rid of that radical. So we're going to solve this using what we already know. We're going to square it on both sides. That's going to leave us with y plus 6 on the right side. And over here, when you square that negative, it becomes positive. So we wind up with y squared is equal to y plus 6. Now, the easiest thing to do here is to get this all by itself, to get that y squared and the y over to the left-hand side. So we'll subtract both of these, right? We're going to subtract the y, and we're going to subtract the 6, and we're going to bring them over here. We get negative y minus 6 over here. So we wind up with y squared minus y minus 6 is equal to 0 because these guys cancel out. Then we simply do our solving just like we would any other quadratic. We'll break them down into two factors. set those equal to 0. So we wind up with a y and a y because it has to be y squared. And we look at this, we know again that this is going to be, one's got to be positive and one's got to be negative. And we've got a negative 1y, so we need two factors of 6 that give us a negative 1 when we add or subtract them. So 2 and 3, if I subtract those, I can get 1. And I want to make sure that the 1 is negative, so I put the bigger number here. So that when I combine them, y squared minus 3y plus 2y, the negative 3y and the positive 2y give me a negative y, and I multiply those out, and that gives me negative 6. So I know that I have two good factors here, and then I'll set them both equal to 0. Y plus 2 is equal to 0, or y minus 3 is equal to 0. And then I subtract from both sides, and I'm going to get that y is equal to negative 2, and y is equal to positive 3. Those are my two possible solutions. And then I need to substitute them in to see if there are any extraneous solutions. Substitute in our negative 2. Negative 2, we want the negative of that, right? So negative y is negative 2 equal to the square root of negative 2 plus 6. Or, right, or we know that it should be that negative 3 is equal to the square root of 3 plus 6. And the negative, again, is coming from up here from the negative y. So in this case, we wind up with 2 is equal to the square root of negative 2 plus 6, which is 4. Is that true? Well, 2 is the square root of 4. So we wind up with 2 equal to 2, and that works. So what about on this side? We wind up with negative 3 over here. And is that equal to the square root of 9? Well, the square root of 9 is 3. This is negative 3, so no, this does not work. That is an extraneous solution. So I'm going to mark it out, and I'm only going to count this one. This is my actual answer. But what about an equation with no solution? What would that look like? Well, let's work this one and see. We've got square root of 3y plus 8 equal to 2, so we're going to subtract 8 from both sides. We're going to get that radical all by itself there. These are going to cancel out. That's going to leave me with negative 6 over here, and the square root of 3y. And I want to get rid now of this radical, so I'm going to square both sides. I'm going to square both sides here. That's going to give me 3y, right, on this side, because both of those are underneath the radical. And over here, I'm going to get 36. And then 3 divided by 3 and 36 divided by 3 is going to give me y is equal to 12. Again, I don't know if it works or not because I haven't checked my solution. So let's try it out. Plug our values back in, so we get the square root of 3 times 12 plus 8 should be equal to 2. Now, the square root of 3 times 12 is 36 plus 8 equal to 2. And the square root of 36 is 6 plus 8. That's going to give me 14. Is 14 equal to 2? It is not. There is therefore no solution. There's no solution because my answer, when I check it, I get two different values. So y is the solution that it should be. And if y doesn't work, no solution.